Okay, everybody, so I'm making this video. It's not live, but I'm going over from Wednesday night's sessions, the challenge problem. So I'm going over kind of the reasonings behind it's a bunch of naming problems, and also an extra worksheet of naming practice. That's what will be included in this video. The actual blank sheet for the extra naming practice was uploaded Wednesday night around 8:15 or so. It is in the folder on the SI tab. I believe it's extra resources. So if you go in there, you can see the naming sheet. It's 25 extra questions. And in this, we are going to go over that again, as well as our Wednesday night challenge problems. Just a few things to say about the exam before getting through this video. So your exam is on chapters 1 and 2. It is a long answer exam. Remember, it is open note. You do not need Lockdown Browser for this exam, and you are permitted any calculator that is an actual calculator. So don't use your laptop or your phone for your calculator. Make sure you have, like a TI-84, TI-86, whether it's simple, whether it's a complex graphing one, doesn't matter. Just make sure you have a calculator because you will definitely need it. I would guess it's probably about 4 or 5 problems. Some of them might have sub-problems. So, for example, if one question is a naming question, within that one problem may be 5, 6, 7 different compounds to name. But typically when these are in paper, they are one page front and back. If that gives you a general sense of how long this will be, you do have the hour to complete it. Is at least what students said. Dr. Katie had said. So hopefully time will not be an issue for you, but definitely make sure you prepare well enough so that time doesn't become a factor. 2 general notes before we get started here. I am trying this new drawing system with a pen, so if it is bad, I apologize. I am trying to get better because as we get into later chapters, it will be more and more important for me to write, and so I'm hoping to practice now, and that hopefully the pain that we suffer through this video and in the near future, will eventually be of benefit down the road. Another thing to note, starting next week, my Husky CT tab will be updated. I am planning on moving to the Zoom platform as WebEx seems like it will limit us every session to 45 or 50 minutes, often causing me to cut my recording in half and making 2 separate videos, which is just not ideal. And so we will probably be moving platforms. But for you guys on Husky CT, when I have changed over, that link should just be the new link. So for you guys, it really shouldn't change much, but it will probably be on a different platform. Okay, so getting into our challenge problems, these ones are very similar to things that have been seen on exams in the past. So this is kind of a naming problem where you're asked to give the name and the formula based on these given descriptions, right? And so this first one says, what is the name and formula for an ionic compound, right? So we're going to have to name it through the ionic method, made of a cation with 24 protons, right? So 24 protons, when we look at the periodic table, that will give us this chromium, okay? 24 protons, and it says that it has a positive 2 charge, okay? So this is the positively charged portion of this ionic compound. Now the other portion, our anion, is made, I'll do this in a different color, halogen is our anion, and it's in the second period. So remember, a period means row of the periodic table. And so if we look at group 17 of the second period, we will find fluorine. Now remember that when we're naming a compound, right, we first put our cation, which is chromium. Now chromium is between groups 3 and 12, which means it's a transition metal, right? So for transition metals, we need to specify the charge after. So chromium 2, now I get the 2 because in the problem, they say it has a positive 2 charge. Okay, so they actually tell me this charge here, and then we put after the whole cation, we put the anion. So it's the halogen, we find out it's fluorine, but remember to change the ending, the suffix, to "ide." Okay, so chromium 2 fluoride. Now, when we're writing the chemical formula, remember that ionic compounds always need to be neutral. Okay, so chromium, our positively charged atom here, we know from the word problem, has a +2 charge. Okay, so +2. Okay, and halogens like fluorine always have a -1 charge, -1. Now, for these to cancel out, +2 and -1, we need to have 2 of the -1 charged species, right? So we need 2 fluorines, each with a -1 charge, to have a total negative charge of -2, which counteracts the +2 charge from the chromium. So chromium 2 fluoride is CrF2. Okay? Now the second one is an acid of a halogen in the 4th period. So again, halogen is group 17, right next to the noble gases, and 4th period is our 4th row counting down. I believe they're also labeled on the periodic table, the numbers. And so when we look across in the 4th period to the halogen group, we find bromine, okay? And so an acid of the halogen, right? All this is saying, and this nomenclature, this wording really was, I'm pretty sure, directly from my exam. It's basically just saying the acid form of bromine, which would be HBr, right? So I can kind of write that first, right? HBr is our chemical formula. And do notice that I wrote aqueous, and this is actually really important, okay? Because acids are aqueous. HBr aqueous is what they're referring to. If you wrote HBr gas, that would be hydrogen bromide, okay? And so it's important. So it's not HBr gas, okay? That is hydrogen bromide. This, HBr aqueous, is an acid, and it's hydrobromic acid. Remember, this is what we call a binary acid, right? It has 2 elements. It has our hydrogen, and it has our other portion, which here is bromine. Whenever we have a binary acid, we name it with the prefix hydro, okay? Then the root of the word, the stem, then the suffix ic with the ending acid, okay? So because it's bromine, it would be hydrobromic acid, okay? Now, looking at the last one, we are again going to be looking at an ionic compound here. Oops, sorry about that. An ionic compound here, and the cation has 29 protons and an equal number of electrons and neutrons with a mass number of 56. So again, mass number is equal to our number of protons plus our number of neutrons. And we're told that our number of electrons and neutrons are equal here. And so first, we find that it is copper, right? Because we can look at the periodic table and find that copper has 29 protons, right? If we ever have 29 protons, we're always going to have copper. Now, number of protons plus number of neutrons equals our mass number. So 29, our number of protons, plus x, which is our number of neutrons, equals our mass number, which is 56. When we solve for our number of neutrons, we find that we have 27 neutrons, okay? And we're told from the problem that we also would have the same number of electrons, so 27 electrons. If we have a compound with 27 electrons and 29 protons, that means we have 2 more protons than electrons, and so we would have a +2 charge. Okay, so that is the reason we know that that is a 2. Now, for the anion portion, you are told that it is phosphate. So for the actual name, all you really need to do is focus on the cation to name it, right? Copper, because there's 29 protons. A charge of 2, because from mass number, we're able to find there's 27 neutrons. And from the word problem, we know that there's also 27 electrons, giving us a +2 charge. and then we're told the anion is again phosphate. Now coming up with the chemical formula for this, can be a little bit more difficult to balance the charges. So something that's important to remember is that phosphate has a -3 charge, -3, and we know copper has a +2 charge. So how do we get this cation and anion to balance in terms of charge? We have to change our subscripts, right? The amount of each ion we have. And so if we have 2 phosphate molecules, each with a -3 charge, we would have a total negative charge of -6. Now if we have 3 copper atoms, all with a charge of +2, we will have a positive charge of +6. And so this +6 charge and this -6 charge counteract. That's how we know that we should have 3 copper molecules and 2 phosphate molecules. Okay. And so here is the next challenge problem. Here we were given chemical formulas, right? We're given the formulas and we're asked to say the name. Okay, and I'm going to start out just by, I'm going to use the little highlight portion, and I'm going to highlight everything that is named covalently. So remember, we have acids that have their own set of rules, we have ionic compounds that have a different set of rules, and we have covalent compounds that have a third set of rules. Okay, so this first one here, right, we have nitrogen and chlorine. These atoms are both nonmetals, helping us know that this should be named covalently. Same with the second one, right? Nitrogen and oxygen, neither of those are metals, so that is going to be named covalently. The next two examples, we have a metal cation, right, in Mn and an Fe, right? These are our positively charged cations, and then we have our negatively charged anions in fluorine and sulfur. So these are going to be named in the ionic method, and so I'm going to underline them like that, or highlight them like that. Now when we look at the next example, again we have a positively charged cation nickel, and then a negatively charged anion, and here we have a binary compound that I am going to highlight. It looks like an acid, but we will investigate further when we get to it. Okay? And so for these first two, again, these are covalently linked compounds. So here, for covalent compounds, we just list the first element here with the correct prefix. So our first element is nitrogen. You will notice that I do not write anything here. I do not write mononitrogen because when the prefix for the first element is mono, you leave it off. Okay? So this is nitrogen trichloride. Okay? Why? Because there's 1 nitrogen and 3 chlorines, and so the prefix for chlorine is tri, and again, the second element you always end in "ide." So nitrogen trichloride. The second one, we do a very similar thing. So here, our first element is not just 1, right? We have 2 nitrogens, and so we have to add the prefix. So dinitrogen. Now we add the prefix for the oxygen, which is tetra, but we drop the A because it's oxide, right? Dinitrogen tetroxide. Okay, and again, notice how the ending is "ide" here. "Ide" here. Okay, with the prefixes in front. When applicable, again, you do not put the prefix if it's mono for the first element. Now, looking at our ionic compound, so Mn is manganese, okay? And we can see from the chemical formula that we have 1 molecule of manganese, a transition metal, for 1 molecule of fluorine, okay? So, to name the cation when it is a transition metal, we just write the name. So we write manganese, and fluorine has a -1 charge, okay? And so to counteract that, we need our manganese to have a +1 charge. So that's how we know it's manganese 1. And then for the fluorine, all we have to do is change the ending to "ide." Okay? Similar process for this next one, right? So Fe is iron, okay, and S is sulfur. So right after seeing sulfur, we should know that the ending should be sulfide, right? The second atom, the anion, we're going to add "ide" to. Now, sulfur typically has a -2 charge, a chalcogen, group 16. So if it has a -2 charge, and there are 3 of them, right? There are 3 of them right here. They contribute a total of a -6 charge. Okay, -6 charge. Now this, because it's an ionic compound, has to be completely counteracted by our iron. And we have 2 irons. Okay, so to counteract -6, we need a charge of +6, which comes from 2 iron atoms, meaning each one is going to have a charge of +3. So iron 3 sulfide. Okay, moving on. Okay, so the next one, we have nickel, Ni, with an unknown charge because it's a transition metal. And then it's with H2PO4. So H2PO4 is actually one of our polyatomics. Okay, it has a negative charge, a -1 charge. Okay, and so to counteract this -1 charge of H2PO4, we know our nickel needs to have a +1 charge. And H2PO4, it has a negative charge, so we know it's not named as an acid, right? It's not phosphoric acid. And whenever you have kind of a weird setup like this, H2 and then kind of one of your common polyatomics, you typically name it in terms of the hydrogens. Okay, so there's 2 hydrogens, so dihydrogen, and then kind of the classic polyatomic, so phosphate. The H2 is the dihydrogen part, and then after it, phosphate. So that whole thing is called dihydrogen phosphate, and that whole compound is nickel 1 dihydrogen phosphate. Now coming to this last one, HF might look like an acid to us at first, but remember, acids must be in the aqueous condition, right? And this is a gas, okay? So because it's a gas, it is named hydrogen fluoride. Hydrogen fluoride because it is a gas. If it was HF and it is, sorry, that should really be a capital F. But if it's HF aqueous, this is hydrofluoric acid. Okay, so again, it needs to be aqueous to be the acid. Okay, coming on to this last side where I ask you to write the formula from the name. Okay, so zinc 2 bromide. This whole principle has to do with balancing charges. Okay, so zinc here, we are told, has a +2 charge. Bromide, aka bromine, has a -1 charge, right, typically. And so for the bromine, to cancel out the +2 charge from the zinc, we need 2 of them. So ZnBr2, zinc bromide. Okay, moving on to the next one. Calcium is an alkali earth metal, which means it has a +2 charge. Okay, carbonate, or CO3 2-, right? CO3 2- is carbonate. Again, has a -2 charge. Our calcium has a +2 charge, and so their charges already cancel out. So it's a 1-to-1 ratio, CaCO3, calcium carbonate. Okay, this next one utilizes one of your polyatomics, ammonium. Do know the difference between ammonium, NH4+, and ammonia, NH3. Okay, so ammonium is NH4+, so it is a +1 charge. Oxide just means oxygen, which has a -2 charge. Right, this is a -2 charge. This is a +1 charge. And so to cancel out, we need 2 ammonias per 1 oxygen. Okay, this is a covalent compound, trinitrogen pentafluoride. So all this is telling you is our first element is nitrogen, and there's 3 of them. So N3. Our second element is fluorine, and there's 5 of them, right? Penta means 5, F5. Okay, and lastly, hydrobromic acid. Okay, so this is the classic naming system for a binary acid. Binary acid. Okay, hydroblankic acid, and because brome is the kind of root of the word, we know it's HBr, and I would notice that I wrote aqueous, which is what's making it an acid. If it was HBr gas, it would not be hydrobromic acid. Okay, so that's a review of the review problems. We are now going to go to the naming sheet, okay, and very similarly go through this. Okay, so there's 13 examples of formulas to names, and then 12 more examples of names to formulas. Okay, so the first one, so as we can see right here, Mg, we have a metal cation, and then sulfur is our anion. So we're dealing with an ionic compound here. Okay, now Mg we know is magnesium. For an ionic compound, we just state the name of the first element, and then for the second element, we just add the anion, we just add the suffix "ide." So magnesium sulfide. Okay. For this next one, this is actually just straight up one of your polyatomics, SO4 with a negative sign. I would pay attention to the charge. Because there is a charge, you know this is not your acid. This is not sulfuric acid. Okay? If it's H and then a polyatomic with a charge, it's not an acid, and this is going to be one of our hydrogen sulfates, right? Hydrogen is the H, the rest of it is sulfate. You can also call this bisulfate. Okay, that is equally correct. Bisulfate or hydrogen sulfate, whichever you prefer. Okay, H2SO3. This has no charge, right? The charge from the hydrogens offsets that of sulfite, SO3. And so when we're dealing with acids, it's ite to us, right? That's kind of our trick. And so it's no longer sulfite, it's sulfurous acid, right? So it's sulfurous acid, not sulfuric acid. Okay, moving on to the next one. Ag is silver, okay, but it's a transition metal. We should theoretically solve for its charge, which I have written as 1. How do I know that? C2H3O2 is acetate, and acetate is a polyatomic with a -1 charge, and so to counteract that charge, silver needs to have a charge of 1. Okay, number 5. Phosphorus and bromine are both nonmetals, meaning this is covalently linked, which means we're using our prefixes. So P, we're just going to write phosphorus. We don't have to write monophosphorus, so it's just phosphorus. And then there's 5 bromines, and so penta, brome, and remember our ending of ide. Okay, HCN, it's the acid form of cyanide. Okay, and so you're really just doing changing cyanide to cyanic acid, right? So it's really IDE. Oop, that's really bad. I apologize there. To ic. That I'm actually doing with my mouse, and I should probably not. To ic. Okay, cyanic acid. HCO3 minus. Again, this minus sign is indicating that this is not an acid. Okay? And it is a different compound. And so this one you can name one of 2 ways. You can name it hydrogen carbonate, okay, or bicarbonate. And you'll notice this is very similar to our hydrogen sulfate, bisulfate circumstance. So whichever one you're more comfortable with. Okay. IO4 minus, again, this is one of your polyatomics that you should know. And again, it follows the general format of X, O4 minus. Oh, this is bad. O4 minus. Okay? And so remember, whenever we have one of these polyatomics with 4 oxygen, our prefix is per, and it ends in 8, with the middle being the root. And so, in the terms of iodine, it would be per iode, which iode is the root, per iodate. Okay, so our compound's per iodate. NO4 to O, right? O is oxygen, so we'll name it as oxide. And the cation portion is our ammonium polyatomic. So ammonium oxide. Not ammonia oxide, but again, ammonium. Okay, Cu is copper, okay, which is a transition metal, so we need to solve for the charge. And so to solve for the charge, we have to look at our anion portion, which is dichromate, right? That's a polyatomic, which has a -2 charge. So to counteract the -2 charge, because they're in a 1-to-1 ratio, right? There's no subscripts, copper needs a charge of +2. Okay. I don't anticipate peroxides being on your exam very much. I think they kind of put it in your chart to make you aware of them. But if you're going to see a peroxide, it's probably going to be this one, H2O2, which is your classic hydrogen peroxide that is probably in your house somewhere. Okay, so be familiar with hydrogen peroxide. Besides that, they typically don't try to trick you with peroxides. Okay. Number 12, we have magnesium, which has a +2 charge, right? Magnesium has a +2 charge, and then we have this anion portion, which is one of our polyatomics, which is permanganate. Okay, so magnesium permanganate, and permanganate has a -1 charge, which makes this chemical formula make sense. Okay, the last one of this portion is H2S aqueous. Okay, there's no charge. Okay, I'll actually write that. No charge. And it is aqueous. That probably indicates to you that this is an acid. H2S is the binary acid form of sulfur, and so it's hydro, root of word, which is sulfuric acid, hydrosulfuric acid. Okay. Not sulfuric acid, but hydrosulfuric acid. Okay, just to wrap this up, the last couple, now we are translating from the name of chemicals to the formulas. Okay, so most of this has to do with balancing charges. Okay, so iron 3 hydrogen sulfate. Okay, so iron is Fe, and we know it has a charge of 3+, which must be counteracted by our hydrogen sulfite. So our formula for hydrogen sulfite is HSO3, and it has a -1 charge. Okay, so HSO3 with a -1 charge, and so to counteract the +3 charge of iron, we need to have 3 of them. Okay, so FeHSO3, 3. Again, remember, this is sulfite, not sulfate. And so it has to be have 3 oxygens and 3 hydrogen sulfites. Okay, moving on to 15, barium carbonate. Barium is an alkali earth metal, right, which is group 2. They have a +2 charge. Okay, +2 charge. And carbonate, CO3 2-, one of your polyatomics, has a -2 charge. These charges cancel each other out already, and so it's just BaCO3. Okay, ammonia is just NH3. That's something to note. Definitely remember that ammonium is NH4. Okay, let's try to NH4, which has a positive charge, is ammonium. Okay, ammonium is NH4+. Okay, CH4, this is again methane. These are kind of ones that they do expect you to know. Ammonia, methane, water. I believe it's probably, I think, the last slide that Dr. Katie posted for your weekly, or I think maybe Dr. Quardokis did the lecture on this. But these are ones that they expect you to know, both ammonia and methane. Moving on to 18, calcium. So this is again another alkali earth metal with a +2 charge. And then hydroxide, which is one of your polyatomics. It's OH-, so it has a -1 charge, which means to counteract the charge of calcium, you just need 2 of them. Okay, so CaOH2. Magnesium cyanide, again, we're dealing with an atom with a positive 2 charge. Cyanide, Cn, and it has a negative 1 charge. In order for the charges to counteract, you just need 2 of them. Okay, so that's kind of the trick to that naming one. Moving on again, nickel 2 acetate. Okay, so we know nickel here has a positive 2 charge because they specify that. So nickel, and then acetate. So we know acetate's one of our polyatomics. It is C2H3O2, and it has a negative 1 charge. So in order to counteract the positive 2 charge of the nickel, you need 2 of them. Okay, so it's NiC2H3O2 and 2 of them. Very important that. Okay, Hypochlorous acid. This is another great one because it's tricky. It's trying to remind you the difference between the prefix hypo and hydro. Remember, hydrobromic acid is for binary acids, right? These are binary acids. It's the hydrogen in the atom. Hydroic acid. This is not like that. This is hypo root us acid. This is indicating that it is coming from the general format XO1 to the negative first, right? There's one oxygen, and this is probably a halogen, right? Hypochlorous, it's saying that X here, the chlor part, is telling you that the X is chlorine. The hypo and the ending is telling you that there's just a singular oxygen, and it's an acid, so HClO. Okay, just the last couple. Nitrous acid, the suffix "us" is telling us that it came from nitrite, not nitrate. Okay, remember it's... Oh, I just completely screwed up there. Sorry about that. Remember, I'll just kind of write it. It is ite to us. Oh, this is tough. I'm so bad at writing with this. But it's ite to us. So if it's nitrous acid, it meant that the prefix that it's coming from is ite, which is NO2, right? So it's HNO2. HNO3 would have been nitric acid. Okay. Gold 1 chromate. So chromate is one of our polyatomics. It's CrO4, and it has a negative 1 charge. And so it offsets the positive 1 charge of gold. Gold is Au. This is not typically one that they ask about. So if you didn't know gold is Au, you are probably fine for this exam. Okay. Moving on, calcium bisulfate. So calcium has a positive 2 charge, right? Positive 2 charge. And bisulfate. So bisulfate is HSO4. And it's, sorry. That should be a 1. This is a 1. Oh, that's just terrible. I apologize again. Again, it is a learning curve. Okay, so let me just try to fix this a little bit. Okay, minus 1. And so in order to counteract the charge from calcium, plus 2, we need 2 bisulfite molecules. So calcium, HSO4, that's bisulfite, and we need 2 of them to counteract the charge from calcium. Okay, the last one is chromium 3 permanganate. So chromium is Cr. I'm sure you kind of got that from polyatomics like chromate, right? So chromium has a positive 3 charge, and we have permanganate, which is MnO4, and that has a negative 1 charge. Okay, negative 1 charge. So to offset the positive 3 charge from chromium, you need 3 of them. Okay, so that is a review of the challenge problems from Wednesday, the 16th. Challenge problem questions as well as the extra naming worksheet. Now this blank worksheet here is posted on the SI tab in the folder called Extra Resources. It's called, I think, Naming Practice. And the challenge questions, if you didn't see them, are at the end of September 16th lecture right there. The last 3 slides or so, last 3 or 4 slides from that lecture, so you can find them without the answers there if you weren't able to find it. Okay. Best of luck studying for this exam. If you have any questions you can regarding content for this exam, feel free to email me or try to schedule some office hours. And best of luck to you all.